Hello everyone. In this session, you will be having a different approach to learn trigonometry. Something like this, a right triangle, which is in front of you, comes to your mind, where we had named perpendicular as P, base as B, and hypotenuse as H, and there was some angle theta as shown in the picture. And with help of these PBH, we tried to define some trigonometric ratios. Most of them were nothing but sine theta, cos theta, then perhaps tan theta, and so on. Now, there was some condition on theta, that theta was always between 0 degree and 90 degree. For obvious reasons, I guess. That if theta is more than 0, then you can have a triangle as shown in the figure. And obviously, when one angle is 90 degree, then how about the other angle, theta? So obviously, there was some condition on theta when we had this right triangle approach to the trigonometry. And with help of this condition and the naming as shown in the picture, PBH, we defined sine theta as P upon H and we defined cos theta as B upon H. So remember one thing, this sine theta and cos theta definition, this is applicable only under the condition theta between 0 and 90 degree. Now I am taking some particular cases. What about if theta is 0? Then if theta is 0, then OB will fall on OA, obviously, and then there would be no triangle, isn't it? So theta equal to 0 is ruled out. If you are learning trigonometry in this approach, we will not have answers when theta is 0. Also, when theta is 90 degree, then what happens? Now theta 90 degree means, as I'm showing in the picture, something like this will come in front of you. That there is base, there is perpendicular also, but that hypotenuse will be now a vertical line. So two vertical lines you just get. So there is no triangle formed. So understand one thing, when theta is 90 degree, then no triangle can be formed. So theta equal to 0 degree and theta equal to 90 degree, there is no possibility of any triangle. Forget about right triangle, right? And then also it comes to my mind, then if there are some cases like theta equal to 0 and theta equal to 90 which are troubling, then can there be more cases? Like what if theta is less than 0? Now those who are drawing the picture and seeing, for them it would be a difficult situation right now to think that can theta also be less than 0? Yes, theta can be less than 0. Answer to this situation would be in our next sessions. And also one more I think of, the another condition, that what if theta is greater than 90 degree? Theta greater than 90 degree means there will be one angle which is more than 90 degrees. So picture would be something like this as shown in the picture. And there I have deliberately shown the arrow. That arrow tells me that it is as if point A and point B, they will be moving on a circle. It looks like some arc kind of thing. So this is one hint that here onwards, perhaps we will not be learning trigonometry with help of a right triangle, but we will be learning trigonometry with circular approach. So this is a new point from where your trigonometry would be refined. Also, you had measured theta in degrees only in your previous classes. So if length can be measured in meters or feet, like our systems in science, what you have learned, like FPS system, MKS system, that means there can be different systems to measure quantities. Same way, theta can be measured in some other way also, not necessarily in degrees. So we may have to learn in which other measures you can see angle. So these are the two new things from where we will be starting our trigonometry, which are different from what you have learned in your previous classes. Just now I have said that we will be having a circular approach to trigonometry here onwards, and our theta can be measured perhaps in some other system. So keeping that in mind, we start our next part. Here I am considering an arc AB of a circle with center O, and also I will be having length of that arc AB same as OA. OA is the radius. That means what we are doing, we are taking an arc AB from a circle whose center is O, such that its length, arc length AB, is same as that of the radius. And then if I join O to B, I find that arc AB subtends some angle at center O. That angle BOA, which is subtended by arc AB at the center, this is called 1 radian. So whenever you want to understand what is 1 radian, you have to take an arc from a circle whose length is same as that of the radius and just check for the angle subtended by arc AB at the center. That is nothing but 1 radian. If you want to measure it by protractor, you may get that in degrees, not in radians. Here, 1 radian's definition is this, as shown here in the picture. So let me define once for all. What is 1 radian? Now, 1 radian is the measure of an angle subtended by arc AB at the center O, and length of the arc is same as that of the radius. Then angle subtended by the arc is 1 radian. And I am showing here that 1 radian as 1, and at the top I am showing C, which is in front of degree notation. I am writing here C. That means whenever C is appeared at the top, your angle is in radians. Okay. So with this picture, you will always remember how 1 radian is defined. I'm sure now most of you must be thinking that, okay, now I know what is 1 radian and I have seen angles in degrees. Then is there any relation between radians and degrees? Obviously, because degrees is known to you and now you are learning radians. So your first thought would be that, is there any relation between radians and degrees? Yes, there is some relation. Pi radians equal to 180 degrees. You can remember this as formula. You can by heart it. Pi radians equal to 180 degrees. This formula will help you in converting radians to degrees or degrees to radians. Now, from where it has come, let us not get there. This formula is important. Pi radians equal to 180 degrees. Now, before proceeding further, I go for some illustrations. Convert the following angles given in degrees into radians. And just some 3 angles I am writing here: 45 degrees, 75 degrees, and 225 degrees. I have taken here degrees to radians. So obviously, in like how you have done in previous classes, unitary method, by that I write on the left degrees and on the right radians, because that is required in the answer. So 180 degree equal to pi radians. Now I'm using the formula pi radians equal to 180 degrees in the other way. 180 degrees equal to pi radians, and then 45 degree is how much? So by unitary method, we know how to write it. 45 into pi upon 180. You can make simplification and you get answer as pi by 4. So 45 degrees is pi by 4 radian. We are doing it for the first time, so I had to do all this calculation in front of you. But here onwards, some angles in their radian form instead of degrees, you can remember them by heart. One of them is 45 degrees and answer is pi by 4 radians. Now go for 75 degrees, exactly in the same manner. 75 into pi upon 180 radians. Simplify this further. That I have done by cancelling by 15. So 5 pi by 12. So 5 pi by 12 radians is same as 75 degrees. Now take that last one, 225 degrees. How will we write now? 225 into pi upon 180. You can simplify this further and you get answer as 5 pi by 4 radians. So just some 3 angles I have shown how to convert degrees to radians. Similar, some examples you can try on your own where radians to degrees you will be converting, and there we will be starting from pi radians equal to 180 degrees. Now remember this formula is pi radians equal to 180 degrees. Now let us make some list of angles, out of which 45 and 75 we have already done. Now I'm adding to the list 60 degree and 90 degree also. You can convert them to radians like the calculation what I have shown before. So 45 degrees is pi by 4 radians, 60 degrees is pi by 3 radians, 75 degrees is pi by 12 radians, and 90 degrees is pi by 2 radians. 60 degree, 90 degree, these angles you have already seen somewhere. So I tried to keep this in the list. And also, other than these four angles, some more angles I am adding, out of which again 225 you have already seen. So 120 degree, 135 degree and 360 degree, these are new to the list. 120 degree comes out to be 2 pi by 3 radians. 135 degrees comes to 3 pi by 4 radians. 360 degree comes to 2 pi radians. And how 225 had come to 5 pi by 4, that we have already seen. So here still I have taken only 8 angles. Other than these also you will be seeing in future where you need to have angles in radians, not in degrees. But if you know in degrees, you can convert, as we have discussed before, how that degree angle will be converted to radians. So realize one thing, that this is the table which I have given from my side, which you need to remember. You can add more angles to this list and make your list ready. I have already mentioned what is 1 radian, and now you all must be waiting for that what will be our circular approach to trigonometry. And for that, I'm showing here x-axis, y-axis, origin O, because my approach would be not only with help of circle, but also in coordinate geometry way. Now, what we do here is that we take a circle with unity radius. Unity means 1. So that is just 1 unit, same as like how you had units in geography. To show the length or distance, you were writing there so many kilometers equal to so much unit. Same way here I am saying, suppose the radius of the circle is 4 centimeters, then my scale would be 4 centimeter equal to 1 unit. So somewhere if you see 2 centimeters, I will be writing that as half unit. So it is just a notation that instead of saying 4, I am writing it in terms of unit. So I consider a unit circle. Unit circle means whose radius is 1 unit, and that circle has origin as the center. And then next I take as point P. Point P I am showing here deliberately in the second quadrant. Why? Because any angle, if you measure in the first quadrant, that angle would be less than 90 degree. And we are looking for the solution, that what if angle is more than 90 degree. So let that point be for the time being in second quadrant. If you understand situation in the second quadrant, then as well you can understand for first, third and fourth quadrants also. So point P is a moving point, which is as shown in the picture, and OP makes angle theta with positive x-axis in anti-clockwise direction. That direction I am showing with arrow. That direction matters. Now, that means what all I have mentioned here, that theta is in radians, and with positive x-axis, angle would be measured. And whatever angle you are measuring with positive x-axis, that is to be taken in anti-clockwise direction. Okay. So with this, I show some important positions also, like A, B, A dash and B dash. Why they are so important? Perhaps maybe in our next session somewhere you may get their answer. So what is our next thing? You all must be waiting for that. That how we define cos theta and sin theta. So take the definition. Cos theta is x coordinate of point P and sin theta is y coordinate of point P. So you know how to measure x coordinate and y coordinate. Like it is just a simple exercise of coordinate geometry. Whatever coordinates you will get, x coordinate would work for answer for cos theta and y coordinate would work for answer for sin theta. And this is the definition which we are not going to question. This would be the basic step to understand trigonometry in our future sessions. And also remember, as I said, positions A, B, A dash, B dash are special positions. Those who are curious to know, they can start thinking on this, and maybe in our future sessions you will get answer for this particular question also, that why are these important positions. Now you know definition of cos theta. So let us take one example. to understand that how we actually are going to evaluate cos of some angle. Now that angle can be more than 90 degree also. Keep that in mind. So deliberately, as an example, I'm taking how to find cos 120 degree. So what comes to your mind? From where we need to start? So what should be our working? That we will have to take a circle of some radius. Say I have mentioned here, say 2 centimeters. I will draw the circle, and how that 120 degrees to be shown, we will have to draw a line which makes angle 120 degree with positive x-axis in anti-clockwise direction. I hope you remember all this, that angle is to be measured with x-axis, positive x-axis to be precise, and angle is to be in anti-clockwise direction, and the required angle is 120 degrees. So we will have to draw a line which makes angle 120 degree with positive x-axis, and I have shown the point where that line meets the circle as point P. So coordinates of point P will answer for cos 120 degree and sin 120 degree. So x coordinate actually we are looking for. This is the story behind this working, that why are we doing it so. So our theta here is 120 degree, and then that theta I am showing here in the picture also. I have shown the corresponding angle with arrow also to make you realize that that direction is important, right? Now what should be our next thing? As I have already given you hint that we may be looking for x coordinate. So I draw a perpendicular from P to the y-axis, foot of the perpendicular I'm showing as M, and then what we do, that we extend that PM to another point N such that PM equal to Mn, and then join O and N also. Now what comes to your mind? That OP is same as ON. Both are nothing but radii. So unit radius circle if you have taken, that means OP equal to ON equal to 1. And we have already seen PM equal to MN also, and OM is common. So triangle PMO and angle NMO, they are congruent triangles. Now, once you show that these two are congruent triangles, then obviously their corresponding parts also you will be equating. So angle POM and angle NOM, these both would be equal, and they are nothing but 30 degrees. So totally angle PON is now 60 degree. And the moment you get angle PON as 60 degree, what comes to your mind next? The triangle PON is an equilateral triangle, right? And by doing this, what are we getting further? That PN is also 1. And we have already uh, constructed as PM equal to MN. That leads to what? That PM would be nothing but half unit. And how PM helps us in getting x coordinate? X coordinate of point P is length PM with negative sign. Why negative sign? Because point P is on the left side of y-axis, so its x coordinate is to be considered with negative sign. So what next? X coordinate of point P comes as minus half. And what x coordinate actually stands for? That is nothing but cos of that angle what OP makes with positive x-axis. So cos 120 degree is minus half. This is how we have evaluated cos 120 degree. Now my request to you is that you can take various angles and do the similar exercise as I have actually done in front of you. Now some of you may think that why I had to take the geometry approach. Okay, if you have some other method, you can go by that. I'm sure most of you would say that we could have answered for this situation by our 30, 60, 90 degree property also, what we have learned in geometry. Go ahead, no problem. My main aim is that you get length PM, and once you get length PM, that means you have almost reached the final destination, that I am in position to get x coordinate. Let me extend that cos 120 degree further. Can I use it somewhere so that more clarity comes to your mind? I take another illustration as how to find cos 1200 degrees. Now, please don't think that 1200 degrees is 10 times of 120 degrees. So perhaps their cos of that angles also. related in similar manner. No. I think then you are on the wrong track. Now 1200 degrees, first of all, you should understand the interpretation. Interpretation is that 1200 degrees is 360 degree plus 360 degree plus 360 degree plus 120 degree. Now 360 degree is familiar to you. It is considered as one complete circle. So my approach, like before, would be with help of one unit circle only. And then I consider initial position as position A. From there, that my moving point P would start moving. And then it completes one circle, arrives at position A, means first 360 degree is completed. Now, if it moves second time, then another next 360 degrees would be completed. And third 360 degree would be completed if point P takes the third circle. In these three circles, total angle covered is 1080. It is not yet 1200. Still angle 120 degree is left. So first it completes what first circle, second circle, third circle, and then additionally 120 degree is to be shown in the picture. So how do I do it? I draw line OP which makes with positive x-axis 120 degree, and that would complete now my 1200 degrees. Now what do you observe here? It is the same position P which we saw in case of cos 120 degree also. Similar picture we had drawn, that angle 120 degree we tried to draw, and then from there we had found cos 120 degree. Now same position you are getting for 1200 also. Now can one particular position have two x coordinates? No, that means point P's x coordinate in the present picture would be referred to as cos 120 degree, or if you wish to, you can say cos 1200 degrees also. Cos 120 degrees answer we know, that was nothing but minus half. So cos 1200 degrees would also be nothing but minus half. So in this way, I have found with help of cos 120 degree, how much is cos 1200 degrees. So similar, more angles corresponding cos we find out, and then maybe for larger angles we can use them as well. So what all we learned in this session? Definition of 1 radian, then conversion of degrees to radians, then we defined cos theta and sin theta. We tried to use those definitions and we tried to find cos of some particular angle. Then we used it as extension and we tried to find cos of some larger angle also. And here I stop, and then I will be getting something more in our next sessions. Please, till then, stay tuned. Thank you.